So now we're ready to do an analysis, but we know that this file is integrated. So our first step would be to block integrate the frames into single points. And we can see that easier if we zoom down on the file. So we zoom in on the file, we can see that there are groups of 2 dots together, and this is indicating that we can validate that in fact it was a 4x integration, 4 fields, 2 frames per field, or 2 frame dots, and what we need to do is block integrate these 2 frame dots down to 1. So we're going to use the block integration routine at the bottom of this menu. First thing is we want to show the integration blocks, and it colors each data point alternately red, green, depending on the block size. So right now the block size is 1, but we think there's 2 data points per block, so we're going to click up to 2, and now it's coding each 2 points as red, green. What we see is that these points seem to group correctly, and if they had not grouped correctly, it would be because maybe there was an offset at the beginning. Maybe we started with just 1 of 2 points, and we can change that offset with this toggle. But in this case, we're not improving the groupings, we actually made it worse. So we'll go back to the offset of 0, and now we see that the groupings are appropriate. We're going to save the block integrated data. That means for each 2 data points we're going to get 1, and then we're going to load that file just saved. And up here now we're going to have a new file. We used to have 1,500 data points, now we have about 750, and we've got a new file, and that's what we're going to do our analysis on. Now, our next step is that our light curve is not nice and flat in the baseline because we had some sort of atmospheric extinction affecting our data. So we're going to take this regular light curve and normalize it to the secondary light curve. So we're going to go to the menu item, normalize to secondary, and this particular routine allows you to return to this particular light curve. If we try and normalize it and we don't like the results, we can return to this by restoring the plot data. But to do that, we have to save the current plot data first. So we're going to save it, and the current plot data is saved. We have to press OK here. If this window happened to pop up behind the Google Chrome screen, we just press Alt-Tab and get that window to the front, and then we have to press OK to proceed. We can just normalize against the light curve as is. That's one way. So let's try that first. We're not going to do any smoothing. We're just going to normalize this curve to this curve, and we're going to pick a point that's highest in the secondary curve, which happens to be around point number 1. So we're going to leave the normalization point as number 1. We're going to say normalize against secondary, and we hear a little bell ring, so let's see what is hiding behind here. It says the observation will be normalized when this message is closed. Do not press the button again. If you press multiple times, you actually normalize the light curve again and again, and then you'll actually mess it up. So only do this operation once, and if you don't like the results, go back and restore the plot. So we'll press OK, and now the light curve is normalized. So you see that there's a fairly bright spike here, probably because of this little drop down here. So we can choose to accept this light curve, or we could say, I'd like to smooth this light curve. So let's try smoothing it. So let's restore the data plot, and this time let's smooth it. We'll try 7 times, some small number, 3, 5, 7. We can try whatever looks reasonable. I'm going to try 7, smooth the secondary data, and now you see that we've eliminated some of the real big spikes, and now we're going to normalize against the secondary again. Here's the little bell. There's our window. I pressed Alt-Tab, and we'll press OK, and we don't get that big spike up that we saw there, and that looks like a pretty reasonable light curve. So let's use this in our analysis. So now that we have a normalized light curve, we're going to write that result to the file. And if I get rid of this, we can see down below that we've written a new file named normalized to secondary to the directory. And if we go to the original directory, we now see that we have some new files that were added. We have the original CSV file. We have an R-OTE version of the CSV file. We have a block integrated version of that CSV file, and now we have one that's block integrated and normalized to the secondary. So this allows us to keep track of what we did, and it allows us to come back to the highest level file if we ever want to redo this analysis. So we want to work on that file, so we're going to load the file just saved. And now that's the file of record in our data set here. And so let's go next step to locate a square wave. So we see there's a square wave in here that looks like an occultation. We are going to do we're going to limit our search from around 150 to around 450, and that allows us to bracket the event and cut down on the number of possible searches done. And R-OTE puts in a maximum event duration of 270, which are the green bars, and that brackets our event, and a minimum event duration of 30, which is less than our event, so we know we're bracketing our event. In fact, we can increase these red bars even further to about 120, and that cuts down on the length of time it takes to do the analysis. Now we know our mag drop is around 1 from our path map, so we can reduce the amount of time it takes to run the analysis by limiting our mag drop analysis from about 2 times the mag drop to about half the mag drop. So we would go from 2 to about 0.5. That's a good bracket to make sure that we're covering the mag drop that we're expecting. So now we go to first pass, locate the event, and R-OTE's calculating surfaces. We have a little progress bar up here that runs, and now we're done. And we have a square wave fitted, and that's our first pass, which gives us a rough estimate of the noise, but it gives us the same noise in both the baseline and the event bottom. We want to analyze those separately now that we've actually identified where the event is. So then we can press update estimated noise values from the first pass, and that gives us the noise in the baseline separate from the event bottom, and you see that they are different, and that helps us improve our analysis. So now we're going to do a second pass, locate the event. Here comes our progress bar. Now we're done. There's our event. Now we have data reported. But we're not ready to report out our results yet. We want to analyze the baseline noise now that we've isolated that by identifying the event.